Hi, this is Alex from devstories.eu. Pulumi Infrastructure as Code, Episode 8 of 10. You copy and paste a block of storage and networking code for the 5th time this week. Your infrastructure code is growing, but it is not getting smarter. Instead of repeating identical cloud configurations every time you need a standard setup, you can stamp them out with a single logical unit. That is the focus of this episode: scaling up component resources on Azure. When you start using Pulumi, you declare raw resources, a resource group here, a storage account there. But as your system grows, deploying a standard piece of architecture requires provisioning the exact same set of primitives again and again. This violates the rule of not repeating yourself. Component resources solve this by letting you encapsulate multiple physical cloud resources into one reusable abstraction. Think of a component resource as a custom class you define in your chosen programming language. Once defined, you instantiate it just like a built-in Pulumi resource. Consider a scenario where you frequently deploy static websites on Azure. A minimal setup requires an Azure resource group, a storage account configured for static website hosting, and a blob object serving as the index document. Instead of writing those 3 definitions in your main program every single time, you create an Azure static website component. To build this, you define a new class that inherits from the Pulumi component resource base class. Your class constructor takes a name, a set of arguments for customization, and standard resource options. The very first thing your constructor does is call the base class constructor. You provide it a unique type token, such as custom::infrastructure::static website, along with the name. This type token tells the engine how to track your new abstraction in the state file. Next, you define the actual Azure primitives inside your constructor. You declare the resource group, you declare the storage account inside that group, and you upload the blob object to that account. Here is the key insight. When you create these internal resources, you must explicitly tell the engine that they belong to your new component. You do this by passing the component instance itself into the resource options under the parent property. Many engineers forget this step. If you omit the parent option, the child resources will provision successfully, but they will be treated as top-level resources. Your command line output will be a flat, confusing list. By setting the parent property to your component instance, the engine organizes the state tree. When you run an update, the interface visually nests the resource group, storage account, and blob directly under your custom website component. This keeps your state manageable and your output readable. Finally, your main program probably needs to know the web address of the newly created site. Inside your component, after defining the storage account, you map its primary web endpoint to a public property on your class. Then you call a method named registerOutputs. This finalizes the initialization and ensures the final address is exposed to the rest of your program and printed to the console when the deployment finishes. In your main file, you no longer see the boilerplate. You simply instantiate your website component, pass it an index file, and deploy. The underlying resources are securely managed behind the abstraction. The true power of infrastructure as code is treating cloud architecture like software, and component resources are how you build a standard, reliable library for your team. That is all for this one. Thanks for listening, and keep building.